Hi everyone, welcome back to my channel, and today in this video we are going to study about the data replication commit type. Previously in the three videos we have covered about data replication introduction. We have covered what is the architecture, what are the commit types. We have just do a little bit discussion about it. After that we studied about the master slave architecture. We studied about how the leader replication work, how write ahead logging works. So we have covered a lot of topics. And now we are going to study about three commit types. So I just don't want you to be confused. There are the three architecture types and three commit types. So in this video, we are going to cover all the commit types of the data replication. So without wasting any time, let's get started and study. So first of all, there are three commit types in the data replication. First one is a synchronous, second is asynchronous one, and third one is a semi-synchronous one. Semi-synchronous one is the one that we used mostly in our production. So first of all, let's discuss about the synchronous replication type. Synchronous replication we usually use in the banking system or in the systems in which we need proper consistency of the data. So let's understand it with the help of the definition, and let's understand it with the help of this diagram as well. So what will happen, user will send the request will reach to the server, and after that server will send the request to this master database. So now what is going to happen, master will not respond back directly. When the request will reach to this master database, what the master will do, master will send it to this replica, and replica will save this data. This replica will also save this data. Master will also save this data. So all the three will save the data. Suppose that there are, let's say, 4 replicas. So what is going to happen? Master will save and 4 replicas will also save the data. And after that, when it is saved in all the replicas, then only master will return to the server that the data has been saved, and then server will return to the user. This is the flow. So the important point is that in the master and in the replica, data will be saved. Then only will return. The good part about this is that data is going to be safe. It is going to be consistent, but the problem is going to be that it is going to be very slow in nature, because the data is going to be stored in the master and in all the replicas. Okay, in one single call. The call is coming, then multiple replicas are going to save the data. So it will take lot of time, and after that, not lot of time, but it is going to take more time than a synchronous one and the semi-synchronous one. So of course it is slower than and all the other types. So this is a problem in this, but the data is going to be consistent. This is our first commit type, that is known as the synchronous replication. Now let's talk about the asynchronous replication. So first of all, let's discuss the definition. Leader says okay to the client immediately and send to the followers in the background. So what is going to happen? The user will send the request to the server. Server will send the request to the master database, and now what is going to happen? Master will respond back directly. Like, it means that whenever the request is coming from server to the database, it will receive by the master. Master will save it and return back. Yes, it is saved. But in all the replicas, okay, what is going to happen? It is going to be update them later on. These replicas are going to update with the help of the write ahead logging that we have discussed. But the point is, these replicas are going to be updated later with the help of a write ahead log that we have studied before. So right now it is going to be very fast, because whenever the request is coming, master is returning after saving, master is returning instantly, and replicas are going to be updated later on with the help of write ahead log. So this is very super fast, no waiting time, writing confirmed in the milliseconds. Of course it is going to be faster than the synchronous one, but the risk is if the leader crashes before sending to the followers. Like, something comes, it is going to be saved into the master, but after that, let's say leader crashes, sometimes there can be a problem that the replicas are not going to get the updated data. Plus, let's say if there are, let's say, n number of replicas, let's say there are 10 number of replicas, then sometimes what can happen, that these replicas will going to get the data later on. So for example, if I'm using social media application and if I like someone's post, so they are going to see my like after, let's say, 10 seconds, because these replicas will going to take some time to get updated, and maybe the other person is going to read it from that particular replica. But it is commonly used in social media applications where we don't need that much consistency of the data. Now thirdly, let's talk about the semi-synchronous one. That is the most commonly used replication technique that we use, and usually we use it into the e-commerce. Now we can use it into the banking system as well. So let's talk about the definition first. So what is going to happen? One follower is synchronous. That is not right, I guess, because let's say there are 10 followers. So we can say 3 followers are synchronous and 7 followers are asynchronous one. Okay. And the rest are asynchronous. Okay. Not necessarily one. There can be more than one followers synchronous. So what is going to happen? This means that you always have at least one up-to-date copy. If the synchronous follower slows down, promote an asynchronous one as to sync. So let's say if this synchronous follower slows down, we can add more synchronous followers. This is what it is. This line is trying to say. Most production systems like MySQL, PostgreSQL use these by default. Okay, we usually use semi-synchronous one. That's what I was telling you. We usually use it into e-commerce. Now we usually use it into this banking system as well. It is a common practice. Okay, now what is going to happen? The user will send the request to the server. It will reach to the database, to the master database, and now what is going to happen? Master will store the database, and into the sync, it will store it to the replica. So what is going to happen? Our complete read, like a proper read, will be considered into the master and this particular replica. So the request will come to the master. Master will say send it to this replica. This replica will save, and then it will return back to the master, and we return to the server. So this is known as the proper read into our semi-synchronous replication. Now, whenever the data is going to be stored in this replication and in this master, it is known as the proper read, and later on, what is going to happen? We will send this to these replicas. Later on, with the help of this write ahead logging, we will update this replicas, all the other replicas, how much number of replicas we have, we will update them. So this is known as the semi-synchronous one commit types. So these are the 3 data replication commit types. So that is something that you should know. And this is it for the video, and we will meet into the next video where we are going to start our second architecture type, that is multi-leader replication. That is going to be an important video, so I want you guys to be focused. So this is it for the video, and thank you for watching me, and bye bye.